Okay, we're going to look some at translating quadratics. So let me get this moved over, or I'll put it up here. So on number 1, we've got that it says you're going to graph y equals x squared and y equals negative x squared using a graphing calculator. So if you put that in a graphing calculator, you'll get your dot starting out there and as your vertex going generally up this way, but I'll just draw a general idea of what our parabola is going to look like. So that would be our y equals x squared, moving up that way. And then if I did a negative y equals x squared, then it's going to have the same vertex there and is just going to go in the negative direction. So crossing at the same point. And so when we talk about, okay, what is the negative sign actually doing to the graph? What it really does is it's going to cause it to reflect across the x-axis. So reflect across the x-axis. And so if you have a negative sign, it's just going to basically make your graph flip over. Next, we have y equals x squared. So we'll do that one in blue. And y equals 2x. We'll do is green. And that red or pink or whatever it is, we'll do the 1/2. So starting out with our regular one, y equals x squared. If it looks something like that, then for my y equals 2x, it's going to go up twice as fast as does the x squared. So it's going to be stretched and look a lot skinnier than the other one does. And so naturally, the y equals 1/2 is going to end up doing the opposite. It looks a lot more curved. Let me try that again. Undo that. So just curving more. It's not going up as quickly. So something along those lines. Doesn't look perfect graphing on here, but you get the idea of what's going on. So when it asks what does the 2 do to the graph, it's going to stretch it. And then the 1/2 is going to compress. They call it shrink on here, but we're going to call it compress because it's getting pushed down. Or compressed. Okay, next we have y equals x squared. That we'll go ahead and put on here. So if it looks something like that, then when we do y equals x squared plus 4, that's going to move it up 1, 2, 3, 4. Put a dot right there. And now it's not stretched at all. It's just moved up. So just moving it up. And so that said plus 1. It's supposed to say, what does the plus 4 do to the graph? And that plus 4, and then move it up 4. And then we have the minus 5. So minus 5. 1, 2, 3, 5. Going to do similar thing, just in the opposite direction. And that's a minus 5, not a 2. So the minus 5 is going to move it down 5. And then we'll do x squared. We'll keep it as blue. And as I'm sure you can guess, the only different direction we have to go is left and right. So if I do x plus 3, plus 3 is actually going to move it to the left 3. So plus 3 moved it left 3. And our minus 4 is going to move it to the right. 1, 2, 3, 4. So minus 4 moved it right. And that moved right 4. Okay, so here's our little layout of what everything does. And I like to think of it as we do kind of a game controller setup, that if I do plus K, that moves it up, which means minus K is going to move it down. And going from left to right, I have x minus h, going to move it to the right. And so x plus h, going to move it to the left. So when it wants us to write the equation for the function with the following transformations, when it shifts left 4 units and up 1 unit, I'm going to write it as y equals, and now it's not stretched or compressed, x left 4 units is going to be plus, so x plus 4 squared, and plus 1. And we're using the same form each time. So stretching by a factor of 5 would be saying y equals 5 times x, and to the right 6, going to be minus 6. Or that's squared, and up 2 units, so plus 2. And the last one we've got down here, reflect across the x-axis and shift down 5 units. So y equals negative x, and we're not subtracting anything or adding anything there, so it'd just be negative x squared minus 5. Okay, so that's writing the equation from it. And you will also see just describing the following transformations. So I have something here, the negative first that I notice, I'm going to say that it reflects. And moves. See, plus 2, that would be 2 to left. So moves left 2 and down 1. And for the next one, it would compress by 1/2. and move, let's see, to the right one. Okay, so you kind of have the layout there, and remember I use that game controller type thing to kind of give me some reminders. But that's how we translate those quadratics.